Here we want to prove this identity. It says we'll work with both sides, but the only thing we're going to do on the right hand side is use an even odd identity. So let's do that. We have sine of a negative angle, and we know that's an odd function, and it's the negative sine of that angle. So we have negative sine negative x. This make this a positive. If we make a negative negative, and that'll make that a positive. Now, looking at secant, if we have secant of a negative angle, well, secant is the reciprocal of cosine, and so the reciprocal function will do the same thing, and we know cosine of a negative angle is just cosine of the angle, so secant of a negative angle is just secant of the angle. So that's the first thing we're going to put here, just secant x. And now, that was step one. Step two says use reciprocal and quotient identities on all three terms. So as we look at what we have here, secant, reciprocal identity is 1 over cosine x. And then tangent is sine x over cosine x. Then we have plus cotangent, that's cosine x over sine x. Now it's good to write it down first, and then let's look and see how we're going to enter it. I see that I have a box for the numerator, so I can just put this 1 over cosine x in there. And then I've got the fraction bar already in, and I've got 2 boxes, 1 for each term. And so I can just take this sine x over cosine x and type that in the first box. And then the plus sign's already there, and then I can do cosine x over sine x in the second box. So we don't need any other parentheses or anything because we do have the boxes for each piece. All right, so now that we have that, our next step says get a common denominator and add the 2 fractions in the denominator. And so let's see what we can do here. It doesn't show up this 1 over cosine x here because I haven't been able to enter this in the computer. I can't enter it in the computer and write on it, so that's why I'm doing it this way. But this 1 over cosine x will show up here, and so we just need to work with the denominator part, so we just need to work with this piece. So getting a common denominator, it's going to be cosine x and sine x. And in order to make the first fraction cosine x sine x, it needs a sine x, and it already had one sine x, and they get multiplied, so that's a sine squared x. And then we've got plus, and to get the common denominator for the second fraction, it's got a sine x, so it needs a cosine x, and it already had one, so it's going to be a cosine squared x. So this needs to go in this box, but let's think about this one. There's one box for the whole fraction, so we need parentheses around the numerator and parentheses around the denominator. Now, next step, use a Pythagorean identity. And notice it already has this denominator filled in here. Well, the numerator is sine squared x plus cosine squared x, so that's just a 1. All right, then the next step, it says flip and multiply. Use parentheses around the product in the numerator. So I'm going to write what we have because it's not showing up here since I'm not entering it in the computer. So we had 1 over cosine x in the numerator, and then we had 1 over sine x cosine x in the denominator. So we're dividing here, so we're going to multiply by the reciprocal. So we're going to flip that over and have sine x cosine x, and that's going to be over 1. And what it's telling us here is we need to have parentheses around this, so we know that's all part of that. All right, so that's what this part is what will end up going in this box, except that it did say to multiply, so we don't need these times 1s. So it's going to be a sine x cosine x in parentheses over cosine x. All right, then it says to cancel, And so in this next step, we could cancel the cosine in the numerator and the cosine in the denominator, so that's just going to leave us sine x. And if we look back at the top, we were trying to prove that that left-hand side did equal sine x.